I'm glad India did not land in the same place everybody else has landed on the moon. That's not interesting. You chose a place where no one has landed before, and that's the South Polar region of the moon.
India is already gearing up for its next moon mission, and this time the project is much bigger, complex, and ambitious, with big names like Japan entering the scene. After the successful touchdown of the Chandrayaan-3, the spotlight now shifts to the grand production, Chandrayaan-4. This time, the Indian Space Research Organization, or ISRO, is teaming up with the heavyweight experts from the Japan Aerospace Exploration Agency, JAXA, for the Lunar Polar Exploration Mission, LUPEX. The collaboration is not just about setting foot on the moon, it's a search to answer one of the most tantalizing questions in lunar exploration: is there water on the moon? So how does Chandrayaan-4 stand apart from its lunar predecessors, and how will it revolutionize our understanding of the moon? Well, you're here, so let's find out. India's Chandrayaan-3 recently achieved a historic soft landing on the lunar South Pole on August 23, 2023, making it the first country to reach this unexplored region. Now, building on this success, a new mission called LUPEX is set to make waves in lunar exploration. LUPEX has a crucial mission: to investigate the lunar polar region for the presence and potential usability of water. Now, why is this so important? Well, if there's water on the moon, it could be a game changer for future space exploration and could even become a vital resource for supporting human life on the moon. So, LUPEX has two main goals. First, it wants to figure out how much water is actually there. It will use existing data and gather new measurements on the moon to understand the quantity of water in specific areas. This information will be super important for planning future missions, like how much water needs to be brought from Earth and how much can be used from the moon itself. This can make lunar exploration more sustainable and cost-effective. The second goal is to understand the quality of the lunar water, how it's distributed, the condition that it's in, and its form. This is crucial for figuring out how we can use lunar water for things like life support, propulsion, or even as a shield. To do this, LUPEX will use a high-tech spacecraft with solar cells and powerful batteries, ensuring it can function even during the dark lunar nights or in shadowed areas. But LUPEX is not just about water. It's also pushing the boundaries of technology for exploring surfaces with low gravity. The mission aims to improve mobility solutions, create survival mechanisms for the lunar night, and develop techniques for potential mining operations. These advancements won't just benefit lunar activities, but could also be handy for future missions to Mars and beyond. Now, before we delve into the exciting details of Chandrayaan-4, let's take a moment to rewind and explore the triumphs of Chandrayaan-3.
And the results of this experiment, and this rover, and this lander, the search for water. We think there's water in the South Polar regions for very interesting scientific reasons.
In the lunar adventure of 2023, Chandrayaan-3 went on a mission with a dynamic team, a lander named Vikram, a rover called Pragyan, and an orbiter. Their goal was to unravel the mysteries of the moon. Vikram and Pragyan landed on the lunar surface in August of 2023, facing a tight deadline of 14 Earth days due to the impending lunar night with bone-chilling temperatures. Pragyan, the rover weighing in at 27 kilograms, became the lunar detective armed with cool gadgets like an X-ray spectrometer and a laser-induced breakdown spectroscopy instrument. It quickly got to work, analyzing the moon's surface for various elements. Scientists were thrilled to discover sulfur, hinting at past volcanic activity on the moon. However, one VIP element was notably absent: hydrogen. To track down this mysterious element to complete its lunar investigation, Pragyan embarked on an extended road trip across the moon's surface. Maneuvering Pragyan wasn't a straightforward task, with a cosmic lag of nearly 3 seconds between commands from Earth and the rover's actions on the moon, making it akin to navigating obstacles with a cosmic delay. As Pragyan navigated the lunar terrain, it encountered heart-pounding moments, like slamming on the brakes to avoid an unexpected 4-meter-deep crater and skillfully swerving around another mysterious crater. Meanwhile, Vikram, the lander, took center stage, exploring the lunar topsoil with the Chastity temperature probe. Despite the excitement, Chandrayaan-3 faced the common challenge of no direct observation of lunar ice. High-tech tools like the shadow cam with its exceptional light detection capabilities failed to reveal the anticipated ice in polar craters. Progin's analysis of lunar regolith, or the moon's soil, also showed no signs of water molecules, raising questions about the whereabouts of the water ice detected by Chandrayaan-1. Now, before we move on, don't forget to hit the like and subscribe button to stay updated on the latest science news and fascinating discoveries. Okay. Hope lies in Chandrayaan's 3 data, especially from Vikram's temperature readings. See, these readings suggested that the most promising location for discovering ice isn't on the lunar surface, but concealed beneath it in the moon's subsurface layers. This groundbreaking discovery from Chandrayaan-3 has far-reaching implications for the future of lunar exploration. The moon's soil, with its remarkable insulating properties, could become a natural shield, providing protection against the harsh lunar environment. This opens up exciting possibilities for constructing space colonies that can effectively regulate internal temperatures, shielding inhabitants from the extremes of lunar day and lunar night. Moreover, the revelation hints at the tantalizing prospect of water ice hiding beneath the lunar surface, adding an extra layer of intrigue and potential resources for future lunar missions. But the scientific journey didn't stop with temperature readings. It delved into the chemical makeup of the lunar soil itself. As Progin's laser detector roved near the moon's south pole, it unveiled a rich assortment of elements, including aluminum, calcium, iron, chromium, titanium, manganese, silicon, and oxygen. The star of this chemical show, however, was sulfur. This marked a groundbreaking first ever in situ measurement, confirming the presence of sulfur on the lunar surface itself. The significance of the discovery goes beyond the chemical composition. Sulfur holds the key to unlocking the moon's geological history, formation, and even hints at the potential for supporting plant life, given sulfur's role as a fertilizing agent.
And so a colony on the moon, I don't foresee people living there permanently.
Renowned astrophysicist Neil Degrasse Tyson added his voice to the excitement surrounding India's lunar explorations. He praised India's endeavor, recognizing it as no small feat, a sentiment echoed by many globally. Tyson emphasized the significance of the moon's south pole, highlighting it as more than just a landing site. It's a plunge into a treasure trove of resources, where perpetual shadows and craters may harbor water ice crucial for future human expeditions, and sunlit peaks offer potential hubs for harvesting solar energy. Now, turning our attention back to the highly anticipated Chandrayaan-4 mission, the excitement is at its peak as India's ISRO and Japan's JAXA joined forces for this ambitious lunar exploration. Chandrayaan-4 is set to be a remarkable mission, primarily designed for a lander and rover exploration. The mission's duration is expected to span 6 months, during which cutting-edge technology will be deployed to unravel the mysteries of the moon's South Pole region. Manufactured collaboratively, the lander and rover are products of JAXA, showcasing the collective expertise of the international scientific community. Meanwhile, ISRO has taken the lead in crafting the lander component, bringing India's technological prowess to the forefront of this lunar venture. The chosen landing site for Chandrayaan-4 is the enigmatic South Pole region of the Moon, a location that has become a focal point for lunar exploration due to its unique features and the potential for groundbreaking discoveries. The mission boasts a payload mass of 350 kilograms, emphasizing the scientific instruments and equipment that will be deployed to gather crucial data about the lunar environment. From analyzing surface composition to studying seismic activity, Chandrayaan-4 aims to build upon the insights gained from its predecessors and push the boundaries of lunar exploration. Scheduled to launch from the Tanegashima Space Center in Japan, Chandrayaan-4 will ride aboard the H-3 launch vehicle, showcasing the collaborative spirit of international space exploration. As we eagerly await the unfolding of Chandrayaan-4's mission, it stands as a testament to the power of global cooperation in advancing our understanding of the Moon. The fusion of Indian and Japanese expertise, along with the mission's comprehensive payload and advanced technology, sets the stage for a new chapter in lunar exploration. The excitement surrounding Chandrayaan-4 is not just about reaching new milestones, but about uncovering the secrets that the Moon holds, propelling us further into the realm of space exploration and discovery.